presentation so that you can run the Mentimeter quiz, please?
Sure.
There you go. It's
So I'm going to share my screen. Tell me when.
Yes, we can see your screen.
Okay, so if you've never used Mentimeter before, it's very simple. You just have to connect with your mobile phone or any browser to the internet and connect to menti.com. Menti.com. The interface will request a code, and the code for this Mentimeter is 4486437. And we'll have a set of 5 very simple questions so that we get to know better your environment and your expectation for this presentation. Obviously, the big data subject is very trendy right now. So many providers and editors have been claiming that data is the new oil or the new gold of this period of time. That big data has become something very critical for many big companies. And so the first question is, do you currently have big data applications running in production? You have three possibilities. One is I don't know. One is yes, you do know, and no, you don't have any applications. So once more, menti.com, and the code is 4486437. So far we got one person with actual applications for big data running in production. Okay, so it seems that we are going for a webinar that will just be informative and which is a roadmap view on what we can do in expectation of what's coming up. 6% so far, 7. Don't be shy. Menti.com 4486437. Okay. I'm going to move on. So that was question 1. Second question, which big data technology are you using today? So once more, big data is something very trendy, but it covers a lot of ground. So we have seen the emergence of many different technologies like Cloudera, Hortonworks, and MapR, which are distributions that include Hadoop. Hadoop being I would say the core technology related to the big data applications. And Cloudera and Hortonworks have merged at some point, and MapR has disappeared. It's been acquired by EMC. And Snowflakes, we tend to put Snowflakes also in that kind of technology. We have also public cloud services, serverless capabilities related to AWS, Azure, and Google. And it seems that some of you are already using some elements of those public cloud services. Okay, good. I give you 10 more seconds. Good. Okay. So once more, it seems that you are all curious of what can be done, even though you are not running big data tech right now. 8%. Good. Moving on. Next question. How do you automate big data, or how would you automate big data based application today? If I understand that most of you are not using big data applications in production, but what would you use? So we'll have the ground to cover many different subjects in this presentation, but Control M obviously automates big data applications. Usually Hadoop distributions like Cloudera, Hortonworks, and MapR comes with Oozie. And there is another player on this market, which is called Airflow, which has been developed by Airbnb in the first place, but it's part of the Apache Foundation. And most of you don't know. Okay. Moving on. Okay, 10 more seconds. Okay, good. You've all responded. Moving on. Do you know what big data-based applications are doing business-wise? Usually, it's a question related to the fact that we we realize that the persons that are taking care of automations are not always aware of what the jobs are actually actively doing. As a result, they know how many jobs are automated, but they don't know what the jobs are doing. And usually it's the application managers that are in charge and who do know what is automated business-wise. And we imagine it would be the same for big data processes. Seems that it's the case. Okay. One more vote, maybe. Okay. Thank you. Last question. Have you ever received a big data automation requirement? I expect it's going to be a no, because most of you are not automating applications related to big data right now. Okay. One last vote. Maybe. So it seems that your crowd, which is more interested in knowing what can be done, probably in expectation of moving to of having to cope with big data applications in the future, maybe in the short future. We do know that most of the companies are interested in this, but being interested doesn't mean that you are going to do the dive and to actively develop or invest in big data applications. For any new type of technologies, usually companies are watching one another to see and assess what exactly is done in other companies, and so it makes sense. So Humayun will have to
Yes, Fred.
do with that and explain what we can do with Control M. So I'm giving you back the presentation role.
All right.
You get it.
What screen do you see?
Yeah, we can see your screen.
Perfect. All right. Thank you so much, Fred, and thank you all for participating in that Mentimeter. It always gives us valuable insights, and the main purpose of running those Mentimeters is to understand where do you stand as a Control M user, and where does your organization stand and would like to go, so that we can help you in that journey with our innovations that our company is offering. So with that, I'll start today's session. So what is big data, right? I'm not going to say that lately the term has been under the limelight. It has been there for quite some time now. Businesses, governmental institutions, healthcare providers, FSIs like financial services institutes, even academic institutions, airlines or ministries, any and all are trying to leverage the power of data at the moment. As Fred said, data is the next gold, basically, or even right now, the next oil, because without having the right data, you are unable to take decisions. And taking decisions in enterprises is primarily the foremost activity in order to run your business, in order to generate revenue, in order to improve customer experience, so on and so forth. If we look at the traditional aspect of how data used to be consumed, there used to be data warehouses, there are still data warehouses, but they started tending towards having limitations with the amount of data that they could process. Again, big data generally does not oversee the storage part of the data, but more on the consumption part of the data. So a typical data warehouse having an ETL or a business intelligence tool started reaching the limitation, how to process the particular data, and the challenges started continuing with respect to the type of infrastructure that you would require, the underlying infrastructure, and sometimes to host them on such infrastructure, significant capacity requirements started increasing, right? And then not just increasing because of the data, but also becoming complex to administer, becoming complex to operate, manage, so on and so forth, and hence the bigger price tags. So it is easy to understand, I would say, why big data repositories running on low-cost Linux servers or any other platform, but a low-cost platform with built-in redundancy should practically gain over the traditional data warehouse approach of storing and consuming data. Now, if we speak about big data, of course, it includes the terms like data mining, the activities surrounding data mining, activities surrounding data storing, the analysis of that data, the sharing, whether on-prem, in the cloud, within one organization or multi-organization, and last but not least, the intelligence around it, which comes in the shape and form of visualization. The term is all comprehensive, but it includes the framework. It includes everything. So, along with the tools and the techniques that are used to process and analyze this data. So that's what generally big data refers to. And as most of the technologies nowadays, it is agnostic of any industry that it may have, right? All the way from financial services to public sector, in the middle, utilities, healthcare, telco, or even retail, right? So what is the area that interests us more from a controlling perspective, from an automation perspective, from an orchestration perspective? And that what we have seen is interest is there, interest is huge. However, the production rollout tend to be slower than as expected with the other applications that are out there. One thing that we keep hearing is that a lot of people, a lot of processes within the production environment are still learning about big data, are still learning about this new trend, are still going through and understanding what this basically poses for an organization with respect to including the efficiency, increasing the efficiency, or helping the organization to generate more revenue. So what I'm trying to explain over here is it is not the difficulty of the technology that we've seen. It is primarily becomes a difficulty around the integration of this particular technology that is helping twofold. That is helping to a magnitude that we are unable to, production environments are unable to comprehend, or the people who are running the production are somehow shying away. Okay, so again, it comes back to the whole story of integration of, let's say, the streamlining of the people and process management between development and production. We have come across a lot of our customers that they are huge users of Control M, and also there are huge users of big data. They have numerous processes running, but they're standalone. They're not integrated with Control M. And when we have found out, it was the same answer, that it feels that it is difficult. How do we come about? How do we integrate ourselves? What about our data scientists? They don't understand what Control M is, and the people who are running Control M, they don't understand what data mining is. So how do we basically close this bridge, right? So that's where Control M comes in. That's where the whole idea of complementing big data initiatives, how to complement them, how to help a project which is running in an organization revolving around big data, how Control M plays its role. I'll just take another step back. I mean, this slide basically sums the whole idea around how you are basically consuming this data. Data-driven business tenet is one in every company or organization that they're chasing today. The goal, deliverable insights, actionable insights, results from the raw data that can basically be of help to the marketing department, to the business decision-making department, to the finance department, before time, on time, and not being reactive, right? In the past, they have been struggling with this. The reality is that big data workflows tend to be immensely complex. However, the results are always fruitful, but the project itself, the delivery, the implementation around gathering the business requirement all the way to produce the insights somehow is not just expensive, but also slower. Okay, it's not fast enough in order to just replace and have a big data, let's say Hadoop cluster. I'll speak about Hadoop in a bit, but have something in this middle, which is basically the caretakers of storing and processing the data on top of your current environment, on top of your ERPs or CRMs or enterprise applications, to be able to crunch that data and deliver the insights on time. So it's somehow not fast enough. The reason over there, again, it's the disconnect. The disconnect between these applications, which are considered as the sources of the data, the single source of truth, whether it be a database, whether it be a flat file, an output from your enterprise application or a purpose-driven application for a FSI or a retail or even, a telco. I forgot something which is very important, even sensors. Nowadays, the Internet of Things, right? I forgot to mention that it is very, very much applicable for a lot of industries and all the way towards the business intelligence tools. So the bridging becomes somewhat laborious, somewhat tedious in order to implement, and that's where it becomes a bit of a hassle for an environment to roll out this kind of technology into production in a faster way. Now, of course, even if you do it, even if you, let's say, set up and implement and deploy that project, it is not just, the challenges do not just revolve around having that project go live. Once the project is done, once you have all the cards in place, once the machine starts running, the challenges around operating this also come into play. Operating into this, integrating with other applications, having the ability to understand the single flow, the single pane of glass, single most object starting from your core applications, moving to the storing of itself, and then processing that by the likes of Spark or Azure Databricks in the cloud, or even the Amazon's supplied Hadoop instance, and then all the way producing that result and giving it over to business intelligence becomes a challenge. Because all of these, again, it's the same idea that they don't have the knowledge around the source of the applications or the data that is coming from, and they don't have the knowledge about where that data is going so that it can be distributed, it can be given to the right personas in the environment. But yes, they do know how to store it, they do know how to process it, and that's where Control M comes, right? A typical Hadoop project, as we explained before, a business requirement or a goal is generally established. An application developers, data scientists, and people who are, dependent, or people who are responsible for producing results based on this data, start designing. One of the very first steps that we have come across is almost every single customer, and we spoke about them, is identifying what data, where does it come from, and how do we process it. Almost without exception includes a whole bunch of traditional data. It can be from an ETL, it can be from social media, it can be from a flat file database. If it's a legacy environment, it can be a database export. Now, again, the whole idea comes back that you need to create those bridges between the Hadoop instance, the big data environment, and the sources in order to facilitate the right output. Now, when it comes to the middle part where your data scientists are in place, this is the part which takes immense time, because it's not easy to just create something. It's not easy to just create a script with these tools that are supplied for running your Hadoop instance. It's not easy to just, like a drag and drop command that can help you identify from the source which data is necessary and which data is not. And that's where writing of hundreds of lines, thousands of lines of code, testing it, deploying it comes into the play, and hence, the whole delay in production comes into the play. Because once you have Hadoop I would say big data / Hadoop instance set up in your environment, you will see that regardless of this technology, the output that this technology is offering to the enterprise, every single facet of that organization wants to jump that bandwagon. Everyone wants to consume it because they see value in it. And when they see value in anything in an organization which comes new, the magnitude of the development of entities within that technology starts increasing. And then comes a time when even if you have multiple people thrown at this technology in order to cater to the requests that you are receiving from different lines of business, at one point in time it becomes impossible to cater to these requests, and you require something. You need another technology on top of it, which will basically streamline these service requests, streamline the development of these streams between the sources of that data all the way to producing the results, and that's where we will speak that why control M is necessary. Remember, please, if you have any questions, please keep on writing. Once we finish, once we have a stop somewhere, we'll be able to address those questions. So why control M, right? Number one reason, primarily to orchestrate the data pipeline workflow. Primarily to orchestrate the data pipeline workflow, not just on-prem, but in a multi-cloud environment. Okay. I will speak about that in a moment. When I speak about multi-cloud environment, there is a reason, and it is also has a history behind it. When big data came into the picture, the technology came and people started adopting it. There are reasons which we will speak about, but overall, why control M? Because enabling you to develop, to schedule, to manage, and not just schedule and manage, but also monitor in a comprehensive way, end-to-end workload execution from a single pane of glass, rather than having to interact yourself with multiple different solutions, all the way from the source of the data to the storing of the data, ingesting it into those tools that complement the big data and the Hadoop instance, and then producing the results for giving the output to the business intelligence applications and solutions to produce meaningful results for your lines of business. Benefits of having Control M, as we were speaking earlier, that without Control M, without the orchestration piece of Control M, in order to facilitate the request, the heavy demand from lines of business to have new reports, new analysis on the data that is being produced by the source applications, it basically helps you have a faster Hadoop application implementation. It improves your service delivery. It basically enables, again, continuous integration and continuous delivery with regards to big data workflows in your organization. And I mean, I don't need to explain in detail that what all of these benefits entail, but we all understand that if we improve service delivery, at the end of the day, your lines of business are happy, they're getting the results on time, which basically enables them to make decisions on time, which inadvertently helps generate revenue. And that's what every organization would want. Not just to generate revenue, but also to have a satisfied customer. What do you call it at the end of the day? Now, one way I'll just go into some of the details that why Control M, it's a continuation. Without Control M, as I explained before, you would require, your data scientists would require to rely on, let's say, heavy scripting, would need to rely on multiple different tools in order to go through that journey. of receiving the data, storing, ingesting, and producing the results. Because each of these 4 stages, where the data pipeline starts and ends, each of these 4 stages are, let's say, complemented by multiple solutions out there. It's an array of solutions, because the sources can be anything, as we explained, right? So in order to have this bridge, in order to have the gap removed, the data scientists spend a lot of time for a single request coming from business in order to generate a meaningful result. A lot of time writing these scripts. These scripts, basically what they do is they allow them to identify the source, they allow them to fetch the right data from the source, they allow them to store it in the right place with the right technology, and then they allow them to, it's like a homegrown automation from their side, right? But again, with this kind of an homegrown automation, basically the plumbing increases, right? If you have a clot somewhere, it requires subject matter experts. It requires time. So mean time to repair increases. The possibility of errors increase, and then of course anything like with any code-oriented productionization, you would require those people who wrote that code to understand where the failure comes. So that's where we come in, right? Like with every other integration that Control-M offers, we come in and we give you out of the box drag and drop capability into integrating to those 4 categories, to those 4 stages of that data pipeline, all the way from identifying and transferring the data from the source, having the ability to talk to different kinds of storages, storing that data into the right place, having the ability to talk to the underlying technologies in a Hadoop cluster in the big data area, to like Spark and so on and so forth, to have control over them, to consume that data in the right time with the right approach, and then last but not least, transfer this output to the business intelligence tools so that they could generate the results. We don't just stop there. We go beyond those 4 stages. We also make sure that all of this activity related to each and every data pipeline execution, we apply service level agreements to it. We make sure that notifications are sent across in order to help the audience, in order to help the customer understand where he or she has a problem, has a gap amongst these 4 stages when it comes to data pipeline execution. So please, if you have any questions, do write them. This is just another example. Control-M for Hadoop is an add-on. It's a control module which allows you extensive plugins, extensive capabilities, job types in order to integrate with these technologies, whether it be for the storage, for data ingestion, for data processing, all the way towards some applications, sources like databases from MS SQL, Oracle, banking applications, or let's say telco applications, which are considered as the sources. So primarily the idea is, as we've spoken before, if you look at this particular diagram, I will put my mouse cursor over here. This is the part where Hadoop plays its role. This is the part which is basically creating all the complexity. However, if you look at beyond this, the generation of the right result not only depends on running a Scoop job or a Spark job, or let's say a Hive process to make sure that you have the right results, but also to bring the right data, bring the raw data all across from different sources, making sure that raw data is then distributed properly, unpacked properly, maybe transferred from a ZOS to a Linux all the way to a Unix box. So code change comes into play, right? So code page changes are there as well. Different integrations come into play before that data is given to the Hadoop instance, before Hadoop is even allowed to go ahead and utilize data. And then the story does not end there. The story goes on into once the data is consumed, then the output needs to be again transferred back maybe to the originating source, transferred to something on the clouds, something in the prem, transferred to another business entity outside of your organization, within your organization, and on top, making sure the service level agreement is in place. So what we're explaining over here, or let's say what would be the bottom line, is it's not just about automating the Hadoop, the big data part through Control-M, but again, it's about the instant visibility. It's about making sure, because this particular part over here is part of your extensive business process. When I say business process, it can go beyond the process itself all the way to taking business decisions. Because what is a business decision? A business decision is based on the right information given at the right time to the right people, which can then you consume this data in order to make the right decisions. Okay, so it's not just the business process that needs to be visible, but in order to have the right business decision, you need to have that instant visibility. And that is something that we have seen with our customers that have struggled while having Control-M and still not having Control-M orchestrate the data pipelines. Okay, still relying on other third-party siloed products within the big data space, and then having to troubleshoot errors when it comes overnight or at the neck of time, at the month end, when that particular report was required by, let's say, the higher ups or the people in the marketing to decide whether they should invest on a campaign that needs to be started in 5 days. With that, what I'll do is now I'm going to take a shift. Of course, I'm going to keep all the bases which we were explaining now, I had explained, but I'll just explain something that now, and this is where what I was mentioning a couple of minutes back about the complexity, right? The complexity of having big data, having an extensive data warehouse on-prem, and storing huge amounts of data in order for them to be consumed by your big data pipeline. It started becoming an overhead for certain organizations, and the likes of Amazon and Google took advantage of that, and now they themselves basically offer services, right, in the cloud, to consume this data for you, to crunch this data for you, and then give you back meaningful results. Of course, all depends on the business logic that you will utilize, but it allows you generally to reduce the overheads that you would have. Now, having said that, what I would like to explain over here, it does not stop Control-M. It does not. You may not need to think that, okay, that previously all my entities related to my data pipeline, all my technologies related to my data pipeline were on-prem. I had my admins and everything, and Control-M was talking to them. If I'm going to move to AWS, and if I have a Hadoop job or a Spark process, which is offered by AWS, there's a technology called EMR cluster, would I be still able to monitor it? Would I be still able to trigger it? Yes, of course, because that's where we went as well. Not just providing you the ability to complement your business process with the inclusion of these Hadoop and big data processes for your data pipeline, but also if you would like to offload an on-prem source of data, right? The data is generated from a source which is on-prem. We again come into the picture. We take that data from your on-prem. We take it all the way to the cloud. We can stack it over there into an AWS S3 bucket or a Google storage or whichever storage that there might be. And then we can also initiate the process which requires a Hadoop job to consume that data all the way. After the results are produced, we bring back the results to on-prem and then provide it to business intelligence tools or any tools that they might require. Last but not least, before I move to another aspect, which I will hand over to Fred, which basically caters to the question that may arise in your minds that, okay, if there was no control M or there is no control M, how things are being done. Of course, those 4 stages which I speak about in a data pipeline where we speak about the source of the data coming from, and then storing of the data, ingestion of it, and producing the result. The same has been being done. It's still being done, right? But there are tools, and we'll address that aspect in a moment after this particular slide. And this slide, again, as you may have seen in the previous forums, we spoke about automation API, we spoke about web interface, we spoke about the rich client. Primarily, we again, the same story applies, that Control M is actually designed for multiple roles. Control M is designed for every persona in your organization. And one of the drawbacks, or one of the reasons, let's say, for having big data not reach production in a magnitude that it should, is basically the people in production, the people in operations who are primarily concerned about making sure that operational jobs, operational objects are running on time. They tend to be unaware of those tools that are being used by your data scientists to generate, to activate, to produce the results in that big data pipeline. And that's where the Control M different persona approach comes to help these operations people to understand what they are doing. Now, it also works in the reverse manner. It allows different interfaces that we offer from Control M, such as the IDE, which is basically jobs as code. It allows these kind of data scientists, which are heavy development users, to be able to interact with Control M, to be able to onboard Control M into their data pipeline, and not just design their data pipeline around their technologies while writing hundreds and hundreds of lines of codes. So it works both ways, and that's where, not just from an integration perspective, that we cover the gap of having the data pipeline introduced within the Control M environment, but also introduce the personas to Control M and reduce the gap. So with that, I would hand over to Fred. Fred will walk us through with the comparisons and the differences between what Control M is capable of doing around data pipeline and what other softwares are there. Again, I would repeat that if you have any questions, please write them down so that we can address them. Fred,
yes, there are a few questions from Gavin Goldsmith, right? The first one is this functionality at an additional license cost? I guess we are talking about the Control M for Hadoop plugin. No, because it's a plugin. Plugins such as, Control M for database or Control M for data stage. So this is something you can download from the electronic product directly on the website, right? So from what Control M version is it available? If I'm not wrong, it's been available for quite some versions. If I'm not wrong, from 9.00.
Yes, version 9 was the first to receive the compatibility with even version. There was a release of version 8 that was compatible with the control module for big data. Sorry, carry on.
Well, thank you, Fred. And then does this only support Hadoop? What about AWS Redshift? So again, has a requirement to execute an SAP job to extract the data, move it to AWS S3, then load it into Redshift. And they would like to do this with Control M rather than Control M plus AWS Lambda. So I guess we have a use case when it comes to Redshift, don't we?
My demo includes the job type of Redshift, so yes, it's very much possible.
Perfect. All right. So Gavin, we'll show it to you, and then obviously we'll get in touch soon to fulfill that requirement.
Okay. Shall I carry on?
Yes, please, Fred. Thank you.
Thank you, Mayun. So a quick part, I'm going to be talking about what exists on the market, because Control-M is not the only product that automates Hadoop, obviously, and Hadoop as such is already equipped with elements that enable automation. Mayun has mentioned Oozie. There are other solutions on the market which are open source. So it's always the same story with open source. Obviously, you don't pay for license, you don't pay for maintenance, but as a result of this, you somehow pay a lot for consultancy. And when it comes to support, if you have a big issue in production, you have to rely on what the community has to offer in terms of support. So there are a number of players, so we will cover some of them. And the first one we are going to talk about is Airflow. Airflow has appeared in 2014. It's a huge project that has been created first in Airbnb, and now it's a very huge product in the Apache projects. It's a very much developer-oriented. It relies on a lot of scripting, Python mostly, and it's oriented toward big data and Hadoop. In general, I would say Hadoop infrastructure relies on scripting automation, and that's obviously a big opportunity for us, for Control-M, but it's also a huge challenge for all the structure of the company. Mostly because when a new big data project appears that relies on Hadoop, the developers will not, most of the time, think Control-M first. They will think about delivering the project in time, following the request that has been done by the business. And as a result of that, when the product is ready to go in production, they will deliver it with the automation solution that they have chosen, basically. So in some cases, there is a discussion with the application team, and someone will say on the production side that maybe Control-M, which is the main product, should be selected as the core product for automation. And in some other situation, the project arrives in production and, well, cope with it. You have to train your production team to Airflow or Oozie or other products. And as such, it ends up with one more automation product in the basket, in order to be used and to be maintained and to be secured for the production to operate correctly. So for Airflow, it requires a lot of Python capabilities, and you have to invest a lot in the many other elements related to the compatibility between Airflow and the production, and the fact that it's once more an open source, and you have to connect this new capability, this new technology with probably Control-M. It's feasible to do it, but obviously it's not ideal. And obviously the monitoring of Airflow will be done in Airflow, and the monitoring of Control-M, even though it could be connected with elements like the supervision solution, has to be done separately. So at the end of the day, what we can say is that Control-M can integrate with Airflow, meaning that there is an application integrator solution related to Airflow. Control-M can automate jobs that have been designed in Airflow. Some customers have already done that, and we do understand that in some cases and occasions, Airflow is a very good solution, but probably it would be also a better solution to choose Control-M right from the start and to use it to automate the whole landscape, as Humayun has shown, to automate the whole landscape from the data generation of the data arrival up till the end of the sequence of automation. Next slide, please. The next obvious competitor is Oozie. So as I said, Oozie, well, there are different solutions on that ground, but Oozie is the preferred and delivered with Hadoop job scheduling solution. So Oozie is interesting. It's very made for the automation of Hadoop infrastructure, but it only does that, meaning that you have mostly capacity to automate only the Hadoop infrastructure and not what's not big data driven. So if you need to synchronize Oozie with other elements like SAP, like file transfer, like even reboots or backups, you will have to create bridges to connect your Oozie jobs with Control M or other scheduling solutions. So that's one big challenge. The other element is that it's in its engine of automation, the core of the automation, and it's at some level the same issue with Airflow. The engine of automation is very poor. It's very mostly comparable to crontab, basically. So when you have a business guy coming up to you and asking you to automate things on the third Tuesday of the month, if it's not an open day, you have to move the automation automatically to the previous Wednesday. The automation engine is not made to automate that kind of complexity, whereas Control M can do that. So for Control M and Oozie, we have obviously the control module for Hadoop, which includes the capability to give order for Control M, to give order to the Oozie infrastructure and to automate jobs that have been defined in Oozie. So that's another point. Once more, I would come back to that. When the project, the Big Data Hadoop project starts, the developers, the Hadoop developers will think Oozie first. And embarking Control M in the first place is usually the better choice, especially if your company has already production guys that are very much accustomed to Control M usage. And as you can see, Oozie is very limited in terms of capabilities. Next slide, please. So the goal, once more, is to simplify the data pipelines and to be able to deliver a world-class, best-class service to your applications. And when it comes to automating big data applications, the sequence is much wider than big data as such. Big data receives data, process data, crunches data, and delivers something else, a subset of the data. We'll see the use cases in the next part. Control M has the capability to automate everything through and through and to deliver you with a global view, a global monitoring view of the processes. Next slide. One more element. As you all know, Control M is delivered with a conversion tool. And in the last versions, it's been 2 years now that it's in the conversion tool, there is a Hadoop Oozie converter, meaning that if you are facing the situation where Oozie comes in production with the big data application and you couldn't do anything to change the situation, well, you can still use this conversion tool to extract the jobs from Oozie and to get it as XML format to be inserted in Control M. And as such, you can recover everything that was designed in Oozie to take it to Control M. And Humayun has already explained that you can use jobs as code to define Hadoop jobs. Well, this comes in the continuity of the CI/CD pipeline after conversion to make sure that your big data developers will still be able to have an impact on the development of the jobs in Control M as they would have in Oozie. Next slide.
All right, Fred, that's great. We'll go to a case study, Fred, as we discussed.
Sure. So I will give you one use case, which is Navistar. So Navistar is an American company. They are leading a fleet of 130,000 trucks that are used for the delivery of multiple elements. And obviously, the most important for them is to be sure that those trucks are actually running properly, because a truck that is facing a breakdown is of no use, and it costs money much more than it makes money. So as a result, in each one of their trucks, they had IoT technology, Internet of Objects, meaning that you get many different captors that will be able to feed information on the status of the different parts of the trucks. and the control M and Hadoop are used in order to crunch this data and to make sure that all the processes are done to use Hadoop in order to identify the trucks that require proactive fixing or spare part exchange, I would say. And it's Control M that automates all this, and they make sure that Control M is used to secure the workflow that will enable all the trucks to run correctly based on every data that has been taken from the trucks. The proactive fixing of objects that are related to Internet of Objects, IoT, is also used in many different airplane companies in order to make sure that all the planes receive the proper caring before an actual breakdown occurs. It's a different kind of urgency, I would say. But for Navistar, Control M was really a game changer, and it secures their business in terms of delivery of goods for their customers. Humayun?
All right, great, thank you. So with that, we will move to the demo. I've actually started it, but don't worry. I will bring you up to speed. Just Fred, let me know if you see the screen.
Yeah, we see your screen perfectly.
All right, perfect. So here, basically, I have a demo. Just a reminder, this is V20. Beautiful web interface with everything there. So the demo revolves around multiple use cases, not just offloading of data from on-prem and or let's say another source and take it all the way to RDS, but EMR cluster, but also we're on the fly creating a cluster for just the purpose of consuming a data that would be coming from a particular source, and then utilizing a Spark job to analyze it in the cloud in the EMR cluster of Amazon, and then notify the results through email and SMS. And then all the way down to decommissioning and deprovisioning the whole environment. So primarily, if you look at it, it's a very valid use case with concern to efficiently utilizing a CPU power, licensed CPU power, and the services that you might take from Amazon. You're only provisioning the environment when and where you require the data to be crunched. And once you're done with your portion, it basically decommissions it. And also, if you're worried about storing the result of this particular instance of execution, the transferring back of the data also happens. So whatever the Spark job or the Redshift job would analyze and ingest into the pipeline, it will basically take the output and store it on-prem. You can store it on-prem in order for future analysis. Now, I would say that we can take some time over here for some questions because the creation of cluster takes a bit of a time. So I can't speed that, unfortunately. I did start it before, like 3 minutes ago, I think another 5 minutes. Or if anyone wants to take a bio break, that's also okay. But if you have any questions, please let us know.
I can come back a few minutes on the use cases that we didn't mention while the jobs are running. So another element that I can quote just to give you some background and to give you some perspective on what our customers are doing. I can quote Produban, for example. So Produban is a big bank in Spain, and they're using Cloudera for the Hadoop infrastructure, and they are running scoop jobs, 6,000 of them, meaning that this infrastructure is quite important. Just as a reminder, an average control M infrastructure is 10,000 jobs a day, 10,000 tasks. And the use case in this situation is quite interesting. They offload the data of the mainframe onto the data lake. Thanks to this, and this is control M that is used to do that. So just for those who don't know specifically how is priced the mainframe, you pay your mainframe based on the 4 most used hours of the month, and usually it turns out into millions of dollars or euros or whatever your currency each month to be paid as a rent for your mainframe. And the fact that you offload the data from your database on the mainframe to the big data environment allows SQL statement to take place over the data lake and not directly on the mainframe. And so thanks to this implementation, Santander has been able to reduce a lot the price of their mainframe. And it's a very valid use case on how big data is used. Another use case is a large fashion retailer which has been using Hortonworks. So it depends on the flavor of Hadoop you would be using, but usually we are talking in terms of number of nodes. So the number of nodes in the cluster can evolve over time. So in their case, they are using 16 nodes in production. In France, I've seen 100 nodes cluster in production also. So it's a very huge infrastructure. And this customer is actually using Hive and Scoop jobs in order to automate the whole data flow. So as you can see, the use cases are very different, and they are very much related to the business of the company. So it could be analysis of customer preferences. We are talking about data collected from social networks usually, or from phones. Our mobile phone are feeding a lot of data. It could be proactive notification of fixing of your IoT objects. It could be also mainframe offload. So the limit is the sky, I would say. It can relate to many different things. Humayun, coming back to you.
Yes, Fred, we're just a minute shy.
Okay.
And then we should have a relatively quicker run of all the objects. So we're expecting the provisioning of the service to finish in around 50 to 60 seconds. Let me just explain it further. Then once that is done, primarily we're basically deploying some connection profiles. So even the connection profiles are dynamic, depending on the use case and the execution at the time. Once that is done, we're basically setting up, transferring the data from the source repository off to the Hadoop instance that we will spin up in this job on EMR server, EMR instance of Amazon. Once that is done, then we have a couple of Spark jobs which utilize that data, read the CSV, do a Redshift SQL load into the database, and then visualize the data. Once that part is done, the workflow will then generate a notification depending on who has been listed out or which IoT device has been flagged. It will notify about the preventive maintenance. And once that is done, the rest of the workflow primarily revolves around decommissioning of what has been provisioned for this particular use case. So fingers crossed, Amazon is taking a bit of time. I'm expecting any moment now. I'm sorry for that. Out of our hands. Fred, is it possible we can speed this up on the background? I don't think so, right?
No, it's not in our hands. Once more, Control M is merely the orchestra leader that feeds the launch time. Execution is taking place actually in an Amazon machine right now in the US.
So now would be a good time if anyone has a question, please.
I know you will receive an SMS. Which job?
I have my phone connected on the screen. So once but the provisioning needs to be done first. I think it's just having some workload to process.
So all these could be monitored with Batch Impact Manager, and I think your process is also related to a Batch Impact Manager job.
Correct. There is a Batch Impact Manager job attached to it.
Just a reminder, so Batch Impact Manager is a part of Control M that enables monitoring of SLAs. And as a result, it could send an alarm if the job goes over a certain time or over a certain duration. There you go.
Yeah, so it actually did not go over the duration. Otherwise, it would have highlighted it. The whole flow is still within the accepted time. That's why we have a particular SLA job attached to it. But it seems like still we're under time, under the expected run. So now the cluster has been created. Of course, the interface allows you to look at all the necessary output. Just for the information, which kind of DNS was provided. If you see over here, it's connected to US East, Amazon server, whole, farm. It also tells you which all activities it has done in mounting the volumes, which required volumes were mounted. The setup has been done, and we have a failure.
Well, the workflow looks a lot like what Malwarebytes is doing to crunch the data in order to get the profile of viruses, new viruses on PCs that have been detected. Try to relaunch it.
Yeah, I think it was still mounting, maybe in the background. That's the reason. Anyways, good thing. We know where to put a stop over there or a monitoring factor. All right. So this is unexpected, to be honest. This usually runs without hiccups, but for some reason we're having some kind of.
Okay. Well, once more, you can relaunch it.
Yeah, this is a Java related. Not expecting this, to be honest, but sorry about that. Exceptions are always there, but it can. At least we know that we're capturing the exceptions.
Yeah, and it's proof that the demo is for real.
Yeah, we're not just putting a sleep command in there.
And so what are the next steps of this process?
So there's a Redshift SQL loading. That's basically to compare the source data with the right matrix. And then notification is supposed to come. I think read CSV would take a little bit of time. A minute should be okay. And then we're expecting a notification on my phone. Let's see. All right.
And can you give some details on the way the SMS is sent?
So we're using an external gateway. Hold on. I think it was an update on our system itself. There you go. So we just received the notification from the SMS gateway that we're using. Again, the idea is this can be used. Hold on. Bad time to call, man. So that's the notification. This is the data. If you see there is a pressure indication, there's the moisture, there's the temperature. The idea around this is primarily to use this use case against devices, against vehicles, against let's say sensors that might be in your oil refinery, that might be on your conveyor belt in your production line. And based on their characteristics, now every sensor generates data, and then you can have this kind of service being hosted on Amazon, gather that data. It does not stop you anymore from orchestrating the preventive maintenance or even orchestrating generating meaningful data from these devices. In the past, usually what used to happen was these devices were manned or operated by their own specific softwares, and then data would be offloaded on timely manner. Then this data would be transferred to, let's say, a data warehouse where business analytics would run on schedules. Now, with the inclusion of the orchestration of Control M, primarily you can do it on demand, you can do it on the fly in the runtime, depending on events, or you can do it every 5 minutes. It depends on the use case. So, as I said, you can surround this particular service around repositories. You can pick up, let's say, dynamic IoT devices addresses, and then based on the data that is coming from the sensors, you can compare. And then once you compare against certain set thresholds. So that's what the Spark jobs and the Redshift SQL loading would do for you. And then utilize Control M to orchestrate the whole thing. This was just the process, but once you do that, you can also, have the provisioning done, whether you're utilizing the Google Cloud or you're utilizing the Amazon. So the instance over here, we use the the EMR cluster, but for Google, you can use Google Bricks as well. Or if you have Hadoop set up on-prem, Control M is ready to integrate itself with all of those activities. Fred, would you like to add something before I?
No, I think it was pretty clear. The fact that people can see that Control M can interact with many different type of infrastructure like the cloud, and obviously big data capabilities plus notification through SMS is, I think, a very relevant demonstration of what Control M can provide when used to its full potential.
Perfect. With that, I would also like to remind, and we'll send out invites, there is a webinar on BMC Helix Control M on the 27th. And we'll send out the invite on the follow-up email of this session. Najib, back to you, please. You're on mute.
Maybe Najib is not available. So in order just to conclude, thank you very much for connecting to this webinar. Thanks a lot, Humayun. And if you have any questions and if you want to come back to us, obviously Blue Turtle is there also for you, and we are there for you to answer all your technical questions. And if we can help in any way, please contact us. Thank you and very much.
Thank you.
Have a great
Rex,
day.
would you like to add something?
No, just thank you for everybody for joining, and enjoy the rest of the week and the weekend.
All right.
Thank you. Bye-bye.
Oops. Uh,